This is the first lecture for section 1.3. The first thing we're going to look at it in this section is how to write a set. When you're writing a set, you need to write the set inside the set symbol or brackets, which look like that. And they want us to list all letters of the alphabet that are vowels. Our vowels are A, comma, E, comma, I, comma, O, comma, and U. And that's it, you're done. When you're talking about sets, you have 6 sets of numbers, okay? Those include natural numbers, sometimes referred to as counting numbers, whole numbers, integers, rational numbers, irrational numbers, and real numbers. Let's insert a blank slide here and discuss what each of those are. Okay, so the first thing we have is a natural number. Those are the numbers 1, 2, 3, all the way up to infinity. And then we have the whole numbers, which are the natural numbers plus 0. And then we have integers, which is the positive and negative whole numbers. But up to this point, you have no fractions or decimals. Now, when we say no fractions, think of the fraction 4/2. What does that reduce to? Well, that's 2. So that is an integer because it reduces, okay? But if it doesn't reduce to an integer, you can't include it, okay? After integers, looking back at our set, see, I'm going in order, natural, whole, integer. After integers, you have rational numbers. This is where a fraction comes in. A rational number is a number that repeats or terminates. So it can be a fraction or it can be a decimal. When you think of it as a fraction, it has to repeat or it has to terminate. Example, what is the equivalent of 2/3? 0.66 repeating, so that's rational, okay? What's the equivalent of 4/5? If you punched it in your calculator or divided it out, it's 0.8. It stops, so that's rational. Irrational numbers never stop, never repeat. Oh, my pen got wild and crazy on me there, guys. When we think of pi, we think of it as 3.14, but technically it keeps going and it never repeats and it never stops. That's irrational. The other things that will be irrational will be radicals that are not perfect square. Like the square root of 2. Okay? The square root of 9 is 3 times 3, so that's 3, so that's rational. But the square root of 2 is not. So looking at our sets, okay, what numbers are natural numbers? No negatives and not zero, no decimals, okay? So, do we see a rational number or natural number? 9 is the only one I see. Whole numbers are your natural numbers, and they do have 0 there, plus 0. Integers. 9 is an integer because it's positive or negative whole numbers. 0 is an integer, and so is -4. Rational numbers, 9 stops. -2/7. What is that if you divide that into your calculator? Think about it. Divide it in or work it out by hand, okay? Either way, whichever way you want to go. Now, you got to be careful on this one because 2/7 is 0.285714285. You can see it goes this far before it starts repeating. So that is rational. -4 is rational. 0 is rational. Okay, -4.01001. It looks like it repeats, but do you see how you have extra zeros? So it's not repeating. Okay. We also need in here on the rational one, $3.632 and 18.3737 because the 632 repeats and so does the 37. Irrational is the ones that don't repeat. My pen likes to go crazy on me here. Real numbers is everything you see up there. Anything that falls in these categories is a real number. Okay?